Hey guys, how you all doing? It's Jalajora here again, back with another video from BHM at GCSE Chem, and today we're going to be doing section C5.1, which is called the reactivity series. And I'm really sorry, I didn't make a video yesterday, or obviously, I told you about 2 days before, but yesterday I couldn't make a video because I was basically, I think I needed a break. I was quite busy, and then afterwards I needed a break, so I just thought I'll make a video today. I'll start chapter 5 today, and also one thing about the website is that there's been some complication with the website, and I'm not being able to put the links because basically I'm thinking to host the website on another server, so I'm not finalizing anything at the moment, so I'm not really going to talk much about the website at the moment. Once I get everything sorted out, because at the moment it's not fully sorted out, and so once I get everything sorted out, then I'll put the links there. So I wasn't able to put the links on that day because there was some complication with the website, so I kind of need to maybe host it on another server or something like that. So I'm gonna think host it on another website, and also I think the amount of money they ask for hosting, putting the links on the website is also quite a lot. So I think I'm gonna sort all that out. But so I haven't been able to put the links, but of the videos from C3.2 to C4.9 on my website yet, and I think I'm gonna change the website a bit. So more on that later. When I've fully confirmed all the changes, what's happening. But for now, just know that from now at the moment, for quite a while, there's going to be just the videos going up on my YouTube channel, and that's it, not on my website or anything, until I get it all sorted out. So as I said, today we're doing C5.1, the reactivity series, and I've been the last few sections in chapter 4 were triple science only, for triple science students only, but this is for everyone, so just to let you know about that. And also I've been seeing news about the IPL is obviously starting in September, and 19th of September I think it is, and basically there's been one Indian bowler and 12 staff members of CSK that have Chennai Super Kings that have tested positive, so that's not great. So don't know what effects that would have, what implications, what impact that would have on the tournament, which begins in just over 3 weeks time. So about 3.5 weeks time. So it's really it's going to be interesting to see how things pan out there. But so that was a bit sad since I do support Chennai Super Kings, but hopefully the people that tested positive, they all get well soon. I think a lot of people are saying that the person the Indian bowler, he's the only kind of player who tested positive. The rest were the staff members of CSK, so they weren't actual players. I think they're saying that Deepak Chahar is the one who's tested positive, but it's not confirmed yet. So I'm not going to go into that too much. Just wanted to let give you an update if you follow the IPL and stuff. You probably knew that if you probably know that if you follow the IPL, but there you go. You probably knew that already. But today we're doing C5.1, the reactivity series, and also the video I made 2 days ago, the 1 minute video, I think, or the day before yesterday, the video that I made about not doing a teaching video today, need to upload the link, need to put the links. I'm probably going to delete that video now because it's a bit irrelevant since I wasn't able to even put the links up. So I'm probably going to do that after today. After I upload this video. But so now let's get into the video. Let's get into the lesson. So it's C5.1, the reactivity series, and the book that I'm using is the AQA GCSE Chemistry Revision Guide from Caboodle. There you go. And what else is it about there? What else is there to say? So today we're doing C5.1, the reactivity series, as I said, and if you're following the student book, it's pages 84 to 85 that you want to be on. So let's begin. So most metals are found as compounds in rocks. So know that, you just need to know that most metals are found as compounds in rocks. Many of these metals have been oxidized. Example, they've had oxygen added. and they've been oxidized by oxygen in the air to form these oxides. So to extract the metals, the metal oxide must be reduced. In other words, have oxygen removed. So basically, let me just explain that to you. So guys. So so basically, you have metals which are found as compounds in rocks, basically, and basically, when they're in these rocks, they're basically oxidized by oxygen from the air, and that's why they form these oxides. So when we're extracting these metals, we need to basically, the metal oxide needs to be reduced, and reduction is basically losing oxygen, so having oxygen removed. And being oxidized means basically adding oxygen. So hopefully hopefully that actually makes sense. It kind of from the name you can kind of also make out that like oxidized means addition of oxygen, reduced means reduction, so that means loss of oxygen. So hopefully oxygen removed, so hopefully that all makes sense. And I've also got my fan on, by the way. It's really hot, so I'm feeling really hot, so there we go, just to let you know that. And so the rock that contains enough metal or metal compound to make an economically worthwhile extracting. Wait, let me say that again. Rock that contains, so we know rock contains the metal compound, basically, the metal oxide, for example. Rock that contains enough of a metal or a metal compound to make it economically worthwhile extracting the metal is called an ore. So you need to know what an ore is. So an ore is O-R-E, that's how you spell it, and you need to know the definition of an ore. So it's basically, an ore is basically a rock that contains enough metal or metal compound that makes it basically, metal compound to make it economically worthwhile to extract. If it's economically worthwhile to actually extract the metal, it's known as an ore. So that's what you call it, an ore. And you need to know this definition. I think it's asked quite a few times in exams, I'm pretty sure. And so yeah, just make sure you know it. And so what else is there here? So there's an ore. Yeah. So the reactivity series is a list of metals in order of reactivity, with the most reactive metals at the top and the least reactive metals at the bottom. So now the thing about the reactivity series, obviously, that it should make sense. What I'm saying here. Reactivity series is it's a list of metals with their reactivity, basically, with the most reactive at the top and the least reactive at the bottom. So hopefully that makes sense. It's quite self-explanatory, I guess. But so the most reactive metals form positive ions most easily, because we've been through this. Metals form positive ions, and if a metal is obviously more reactive, then it means it's going to lose its electrons more easily, and therefore it's going to form positive ions more easily. Basically, it's going to form the positive ions most easily, basically the most reactive metals. And just to tell you about the reactivity series, now I'm not sure, I might be wrong on this, but I don't think you need to exactly remember the reactivity series, but I would recommend you actually remember the reactivity series, because it is, unlike the periodic table, like, it's not given to you in the exam. You're not given the reactivity series of elements. I think so that just probably means that you need to kind of know it. And I don't think you need to know all the elements, but you need to have a general idea of kind of where it would be on the, in the reactivity series, and But you know what? I would recommend actually learning the reactive series off by heart. Like, it's not going to be very hard. Like, it's going to be quite logical, actually. Like, if group 1, obviously, for example, are very reactive metals, right? Group 1, the alkali metals, they're obviously very reactive, so you'd expect those to be at the top of the reactivity series. And then and for they'll be more reactive than something like like we've been through it. We've been through the fact that group 1 metals are more reactive than transition metals. I'm pretty sure we went through that or something like that, soon. But basically, when you know a couple of trends, when you know some trends, let me just make sure I'm actually speaking right about transition metals and stuff. I might be wrong, might be completely wrong about what I'm saying about transition elements. But the main thing is you need to basically have let me just see. So group 1, yeah, there's group 1 less reactive. Yeah, so it says here, just make sure I got it right. Transition elements or transition metals are less reactive than group 1 metals or group 1 elements. So you'd expect something like potassium to be higher than something like iron. You know, those kind of things you just need to know. You don't need to have a vague idea. You know, kind of good idea. So I would recommend learning the reactivity series off by heart. It would help you in the exam because you're not given it, unlike you're given you're given the periodic table, where you're not given the reactivity series. So that's very important. And then here's a question. So 1 of 2 questions in this section. So what is an ore? So an ore is basically a rock that contains a metal or a metal compound, and that is economically worth extracting. Basically, that, you know, that's economically to make it, you know, So a rock that contains enough metal or metal compound to make it economically worthwhile extracting the metal, basically. Let me just go through it. Let me just read what it says exactly here. But you need to know this. So rock that contains enough of a metal or metal compound to make it economically worthwhile extracting the metal, and it's called an ore. And that kind of makes sense. You know, you want it to be economically worthwhile. You don't want it to cost that too much money. You know, you want it to be financially. You want it to be a financially beneficial process as well, basically. And if you want to extract that metal, it's got to be economically worthwhile. So that's basically what I was saying, and that should be the answer, actually. And it kind of makes sense. You know, rock from which metal can be extracted economically. So that's, you know, just remember, rock from which the metal can be extracted economically. I would also add that from which so rock from which a metal can be extracted economically. I think, you don't need to put the worthwhile and stuff like that. I think just remember what's in the book here. It's shorter, and I think it's better as well. And now we're looking at metals plus water. So the group 1 metals react vigorously with water, and they give off hydrogen gas and leave an alkali hydroxide solution. You do need to know this. When group 1 metals, when they react with water, they produce alkaline solutions and hydrogen as well. You need to know this. And so, for example, if we have potassium plus water, you'd have potassium hydroxide plus hydrogen. Now, the thing is, I'm not going to go through balancing equations. You should know how to balance equations. That's why I haven't got a paper and pen here. It's a relatively easy section. But you just need to know when, you know, here's, for example, if I'm showing correctly, if I'm showing it properly, if you can see, here's potassium. Am I showing correctly here? Wait, am I showing it right? Yeah. So here you can see, I think here, I don't know, let me get a focus. For potassium, potassium plus water gives you potassium hydroxide plus hydrogen. I really hope you can see this, guys. In fact, you know what, I think, I don't know, should I write this? I don't know. Hopefully you can see this, you know, potassium. There you go, potassium plus water, the 2K, this one, potassium plus water gives you potassium hydroxide plus hydrogen. And it's just a case of literally just balancing equations, and so you should get 2K plus 2H2O gives you 2KOH, which is potassium hydroxide, obviously, and H2, which is obviously hydrogen gas. You just need to know that group 1 metals react vigorously with water, giving off hydrogen and leaving an alkaline hydroxide solution. 1 minute, I think I'll come back in a minute, and I'll get some paper maybe for this one. Come back. I shouldn't have probably gone for that long, but there you go. So let me just write it. So K plus water, and give me KOH plus H2. And you just need to really know this reaction, really. You can't really do much about it. And so this is what I was talking about. And you need to know this reaction. So this, for example, potassium plus water gives you potassium hydroxide plus hydrogen. And all group 1 metal reactions, any group 1 metal you have, reacts in pretty much the same way. You're going to have the metals. The only thing that's going to be different from the equations that you form for group 1 metals is going to be everything else is going to be the same. So that's just in case you couldn't see it. So magnesium metal only reacts with very slowly with cold water. Less reactive metal such as copper does not react with water at all. So obviously we know group 1 metals are very reactive with water. They have a very vigorous reaction. And magnesium only reacts very slowly with cold water, so it's much less reactive than something like potassium. And then copper doesn't actually react at all with water. So you need to know these kind of things as well. That copper does not react with water at all. Magnesium reacts slowly with cold water, and the potassium reacts very vigorously with potassium or any other kind of group 1 metal for that matter. Reacts very vigorously with water. So here's the second question and the last one of this section. Using the reactions of copper, magnesium and potassium with water, place the metals in the order of reactivity. So we've already been through this. Potassium is going to be the most reactive, it's going to be at the top. Then in the middle is going to be magnesium. Remember, potassium is in group 1, it reacts with water very vigorously. And magnesium reacts with cold water very slowly, so that's going to be just below potassium. And then you're going to have copper below magnesium, obviously, because copper doesn't even react with water at all. So that's going to be at the bottom. So hopefully that makes sense. We've just been through that actually, so shouldn't be very hard. Just going to look at the answer to that. And there we go. Wait. The yield of a 1 minute titration. Oh, where am I? Chapter 5, C5.1. There we go. Most reactive is potassium. So from most reactive to least reactive, it's potassium, magnesium, and copper. So potassium is most reactive, copper is least reactive, and then magnesium is in the middle. And now metals also react with metals plus dilute acid. Now hydrogen gas is produced if metals react with water or dilute acid. Now you need to know that when metals react with acid, you form your salt plus your hydrogen. So you form a salt and hydrogen. The rate at which the metal gives off hydrogen can be used to judge the relative reactivity of magnesium, zinc, and iron. So the table below summarizes the reactions of some of the most important metals with dilute acid, and it shows the reactivity series of metals. So basically shows the reactivity series of metals, it shows the reactions of water as well. It shows the reactivity. It shows metals reactivity with water for all the metals, and with also for all the metals reacting with dilute acid, it shows their reactivities as well. So it places the metal in a reactivity series, which I'll show you here. So hopefully you can see all these kind of. Wait, if I make it a bit bigger. Hopefully you can see this all. Hopefully it is quite clear. There you go. There's the reactivity series, and I would recommend you learn this. Not going to go through this much, but like for example, potassium, sodium, lithium, calcium. These all fizz and give off hydrogen, leaving an alkaline solution of metal hydroxide with water. But then they explode with dilute acid, and something for things like and then you have things like calcium, which also reacts vigorously with water. But then you have magnesium, zinc, and iron. These have very slow reaction with cold water, and they fizz off, giving hydrogen and forming a salt with dilute acid. And then copper, silver, and gold, they have no reaction with water or dilute acid. And also calcium, by the way, explodes with the reaction of dilute acid as well, just like potassium, sodium, and lithium. So you just need to know this reactivity series. I would definitely recommend learning it, although I don't think it specifically says you do need to learn it. It would be really good if you can learn it, because you're not given this in the exam, and I think it will just be very helpful if you can for you if you can learn it. Now we're nearly done with the video, but nearly finished with the section. But I do want to give you an example of metal reacting with dilute acid to form a salt plus hydrogen. So let me just do that. So I'm just making sure I'm balancing this very correctly. So for example, you could have any metal pretty much, but obviously copper, silver and gold won't react with dilute acid or water. But like something like magnesium, calcium, potassium, sodium, lithium, any of those can be used basically. And for example here, magnesium plus hydrochloric acid gives you magnesium chloride and hydrogen. So that will be the reaction there. That's the second one I'm talking about, because we've already been through the first one. So hopefully that's alright. And then study tip here is when a lighted splint is applied to hydrogen gas, the gas burns with a squeaky pop. So that's actually a test you need to know for hydrogen. And I think the tests for different compounds, tests for different different things like oxygen, hydrogen, carbon dioxide. I think these will come later as well, but just remember now, it would be good to, if you can get it in your mind now. The more things you get in your mind now, things will be better afterwards for later. So when a lighted splint is applied to hydrogen, the gas burns with a squeaky pop sound. Yeah, squeaky pop. So that's the study tip. And the keywords for the section were oxidized, reduced. So oxidized, reduced, or and the reactivity series is also another keyword. So reactivity series. Wait, let me tell you again. So keywords are oxidized, reduced, or and reactivity series. There we go. And the synoptic link are topic C3. The synoptic link is topic C2.3 gives information about the reactions of alkali metals in group 1. So we've been through C2.3 and we've been through the reaction of alkali metals with group 1 in group 1 basically. Yeah, I don't know why I said with group 1. So topic C2.3 gives information about the reactions of alkali metals in group 1. So we've been through that before. And the key points, just to finish off, are that the metals can be placed in order of reactivity by their reactions with water and dilute acid. We've been through that before. And also the final thing is hydrogen gas is given off if metal reacts with water or dilute acids, and the gas pops with a lighted I don't know why it says spill. I think it's splint, but basically just remember splint really. I think I used to remember splint and that was always correct. So it says lighted spill here, which might also be right, but I would say splint. So the last point is just hydrogen gas is given off if metals react with water or dilute acids, and the gas pops with a lighted splint. So that's basically the squeaky pop sound is basically what is used for the test for hydrogen. Basically that's what the test for hydrogen is. And yeah, that's the end of the section, guys. Make sure to share, like and subscribe. Hopefully it was a useful video for you. Make sure to share, like and subscribe. Turn the notification bell on if you haven't already, so you're notified and updated when I upload new videos you can watch. And yeah, and tomorrow we're doing C5.2, which is displacement reactions. So that's what it's called. So that's going to be interesting. Until then, have a nice day, guys, and thank you very much. Bye.